going to do another redox reaction, but this one's harder because you're starting with one reactant and you're finishing with two. So same thing as last time, we're still going to split up into two half reactions. So we have this going to AsO4 like this, and then we have AsH2AsH3. So we're still going to balance it the same way. We look at how there is one As on either side, so that's good. And then we have to balance the oxygens and the hydrogens. And since this is an acidic solution, we don't have to worry about any hydroxides. We're just going with the hydrogen ions. So there's 4 oxygens on this side, so in order to get 4 on this side, we have to add 4 waters on this side. Okay, so now we have 8 hydrogens on this side and 2 on this side. So 8 minus 2 is 6. We're going to add 6 hydrogens to this side of the equation. So now this should be balanced. We have 1 As on either side, 4 oxygens. 4 times 2 is 8. 2 plus 6 is 8. This one's good. Now we're going to do this one. For this one, we don't have to add any waters. We just have to add hydrogens because there aren't any oxygens on this side of the equation. So since there's 3 on this side, we're going to add 3 on this side. And now we're good. Everything's balanced. So now we're going to do the charges. There's no charge on water, no charge on this. So this side is a charge of 0. All of this is a -1. And this is 6, because 6 times plus 1 is 6. Minus 1 is 5. So this side is plus 5. In order to get 5 to 0, we have to add 5 electrons to this side. So now we have this stays 0. This is 6 minus 5 minus 1, which is 0. Wait, 6 minus 5 is 1. Minus 1 is 0. So yeah, now these should be even. And on this side, we have 0. And on this side, we have plus 3. Same thing as last one. In order to get this to be 0, we have to add 3 electrons to this side. So now we have 3 minus 3. That's the easy part. And now this is 0 and this is 0. Okay, so we see that everything's balanced. The charge is balanced. Yay. But the electrons themselves are balanced. So now we just find the least common denominator of 3 and 5 and get there. And that LCD is 15. So we're going to multiply the entire equation by 3 to get 15, and this entire equation by 5 to get 15. So we have the first reaction first. We're going to do 4 times 3 is 12 H2O plus 3 AS2 3 H2 AsO4 minus plus 18 H plus 15 E minus. That's the first equation. Second equation, we have 3 times 5 is 15E plus 15H plus 5As to 5AsH3. So multiply everything out, and now we're going to combine these reactions, put all the reactants on one side, all the products on one side, and then cancel out what's extra from either side. So we have all the reactants over here, plus 3As, plus 15E, plus 15H plus 5As. Those are all of our reactants. Here are our products. 3H2AsO4 minus, 18H plus, 15 electrons, plus 5AsH3. Okay. So what can we cancel? We have 15 electrons on either side, so those are all gone. There's 18 hydrogen ions on this side and 15 on this side, so we'll take all of these away and change this to 3. And on this side, we have 2 reactants that are the same thing, but with different coefficients, so we can just add these together. So 5 plus 3 is 8, so now we have 8 on this side. And the reason that we can add these together is because they both have 0 charge. They're the same element, they just have different coefficients. It's just like adding like 2x plus 3x, you get 5x. Same thing, we have 3As plus 5As, so we have 8As. And now let's rewrite our entire equation. Let's move this down, hope it doesn't fall. Yay. 12 H2O plus 8 AS goes to 3 H2AsO4 minus plus 3H plus plus 5AsH3. Okay, so this is our final equation. So pretty, but before we turn it in, we have to make sure that everything's balanced, including the elements, compounds, and charges. So we have, let's do the AS first. We have 8 on this side, 3 right here, 5 right here. My 5 looks ugly. So there's 8 on both sides. We have 24 hydrogens, 6 plus 3, 9 plus 15 is 24. We have 12 oxygens, 3 times 4 is 12. And that's all of our balancing for the elements and compounds. And I have to balance the charge. So this side has a charge of 0. This side is 3 minus 3 times the negative. So it's 3 minus 3. That's also 0. So we're all good. Everything's balanced. The tricky part about this reaction is that we started with 1 reactant and then ended in 2. But we're just going to do it the same way. Let's move this back up. Do it the same way. Balance the 2 half reactions with elements, compounds, charges. Find the least common denominator. Multiply to get to that common denominator, which we found was 15. Cancel out what we don't need. Add the stuff that's together, but it's kind of rare, so keep an eye out for that. And then we get our final reaction and double check one more time before we turn it in. So that's balancing redox reaction, an acidic solution with 1 reactant. And let me know if you have any questions.